Okay, today we're talking about functions. First thing we're going to discuss is if a correspondence, a set, or a graph is a function. It's really not hard. All you have to do is consider your domain or your x values. If you have one x value going to more than one y, that means it's not a function. So here, say we have our x values are birthday, y values are people. Two people can have the same birthday, so this would not represent a function. So, nothing. Not on this one, no. Now, if we're thinking about football, players versus numbers, they all have one number. So since every x has one y, that's fine. This is a function, yes. If you're just looking at points, just look at the x values. If you have any of the same x value, it's not a function. So we have 3, 2, and -1. So this is okay. This is a function, yes. Here we have 3, 2, and 3. So no, this is not a function. When we're looking at graphs, you can use the vertical line test. Alright? So what you do is you drag your pencil across the graph. If it only hits one point at a time, it is a function. That's okay. But if it hits any more than 1 point, it's not a function. So this is okay. 1 point, 1 point, 1 point, 1 point. Yes, this is a function. This hits 2 points here or here. Just drag your pencil across the paper. If it hits more than 1 point, it's not a function. So no on this one. And that's definitely not because it does not pass the vertical line test. No again. Okay, next thing I need to talk about is set and interval notation. First, you need to know what to use. So if we're drawing a graph, if it is a solid circle, that's where it's less than or equal to or greater than or equal to, so it does include it, so it's including. And in interval notation, we use brackets. For set notation, we use inequalities. If it's an open circle, we use inequalities without the equal sign because it's not equal to that number. And in interval notation, we use parentheses. Okay? So those go together. So say we had our first example and they just gave us a graph. Say we had a solid circle from 5 to 10. For set notation, okay, we can call this all of our x values. And this is how you write it. It's just the way the notation works. It's from 5. And in set notation, we use inequalities. And since it's a solid circle, we're using less than or equal to and greater than or equal to. So 5 is less than or equal to all our x values, which is less than or equal to the highest value, which is 10. Another way of writing that is an interval notation. Since these are closed circles, we use brackets in interval notation. And it pretty much comes directly from this line. We start at 5, and it's a closed circle, so we use brackets for both of these. And it goes from 5 to 10. So we use bracket, 5, comma, 10. Bracket. Say we had something like this. An open circle going to a closed circle. And it was -4 and 0. For set notation, call our variable x. Doesn't matter which one when you're in one dimension, just across the line. On a graph, it does matter, because on graphs we have the x line and the y line. We are going from -4, but it's an open circle. So, still start with -4. Since it's an open circle, you just use less than. Because we know all of our x values live between -4 and 0. So -4 is less than all our x values, which is less than or equal to, because it's a closed circle, 0. And interval notation just kind of follows through. Since it's an open circle, we're using a parenthesis. So parenthesis -4 to 0 with a bracket, because it's a closed circle. One more type of example with just one-dimensional lines, that's left or right. Let's say it's an open circle, but it's going all the way this way, forever and ever. Well, forever and ever that way is actually called negative infinity, because it goes on forever. And say we had a closed circle, forever this way. Well, this is a little bit different. Say this was 1 and this was 2. So we're just skipping the space between 1 and 2, and we're not including 1. For set notation, x exists. Alright. Well, here, x is everything smaller than 1. And it's not including 1 either. So, it's x is less than, not equal to, 1. Or, I like to use or here, x is everything greater than or equal to 2. And we know 2 is going on and on forever to infinity. For interval notation, pretty much left to right what you see here. Negative infinity to 1. But since infinity is not closed anywhere, we use a parenthesis for it. We never use a bracket for infinity because it's not really closed. We can't say it's a specific number. That goes to 1. Since it's an open circle, we use another parenthesis. When we're doing interval notation, the U in between two of these things stands for union. Alright, so we're kind of combining these two sets. The union of them gives us what x can be equal to. Bracket, because it's a closed circle, to infinity. And remember, we can't close off infinity, so we just use a parenthesis. So those are some different ways of using set and interval notation. Next, we need to talk about the domain and range of functions. Alright, so first, if it gives us a set, and this works the same with the graph, except they have lines, so it's a little bit different. Say we have 3, 2. Negative 1, 4, and 2, 0. If it asks for domain, that means it's just asking for all the x values. So we list it with a curly bracket, 3, negative 1, 2. And you can put them in order if you want. So we could say negative 1, 2, 3. Range, just the y values. 2, 4, 0. Can put them in order, 0, 2, 4. And that would be it. 2. Say it gave us a graph. Just a straight line bounded between 2 points. And we know this point is negative 3, negative 2, and this point is 1, 1. If it asks us for domain, we're just looking at the x values. So domain, we know x is between, go from left to right, negative 3 to 1. There are actually a few different ways we could put this. We could either say, in this is set notation, set. X, that bar means exists, kind of, from -3, less than or equal to x, less than or equal to 1. That's just saying x is between -3 and 1. And since these are closed circles, another way of writing it in interval notation would be with brackets, because whenever you have a closed circle, you use a bracket for interval notation, -3, comma, 1. It's the same thing as this, just a different way of putting it. Range, we can do the same thing. For set notation, except when we're talking about range, we're talking about y values. So we would say y exists between bottom to top, -2 to 1. Always go from the lowest value to the highest value. So we could say y exists from -2 to 1. And once again, another way of putting that in interval notation would be from, with brackets, -2, comma, 1. One more example of this. Number 3. Similar, have a graph. Say we have a point -4, 1, and it goes up to 2, 5, and then it drops back down to 2, -2. Alright, sometimes it's not going to give you the points, so you're just going to have to figure them out yourself. This one's a little bit different. We're not just using the first and the last point, like this one. We have to look at all of them. Alright, so for domain, looking at set notation first. Domain means x, so we write it like that. And x values, we're just looking at where it starts, lowest value, -4, to the highest value, which is 2. So -4 to 2. For interval notation, since they're closed circles, we're using brackets, -4 to 2. Range, very similar. Set notation, we know we're dealing with y because it's range. And we go from the lowest value, which is -2, to the highest y value. It's not here. We have to go all the way up to the very farthest point, 5. So -2 to 5. And I'm using less than or equal to because these hit and they touch it. It's not an open circle. Okay? Next, we're going to talk about function values. Say it gives us some function, f of x. And this is actually the same as y. It doesn't mean f times x. It's pretty much the same as y. So like y equals 3x minus 2. Alright, and then it wants us to find different function values. So if it said f of 2, all it wants us to do, since it was usually f of x, that all it wants us to do is replace x with 2. So it's going to be 3 times 2 minus 2. 6 minus 2 is 4. What if it said f of 2/3? we do the same thing, just plug in. This becomes our x, because it usually is f of x. So we get 3 times 2/3 minus 2. Well, 3 times 2/3, same as multiplying by the top, dividing by the bottom. 3 times 2 is 6, divided by 3 is 2. So we get 2 minus 2, which is 0. For, say, something like f of a. All we're doing is replacing the x's with a's. So this wouldn't change much, just the letter, 3a minus 2. But they might throw a little bit more stuff in there with it, x plus 1. So it wants us to replace our x with x plus 1. So we'd have 3, make sure you use parentheses, x plus 1 minus 2. Whenever we're simplifying something like that, we have to distribute. So 3 goes to both. We get 3 times x is 3x. And then 3 times 1 plus 3 minus 2, which would be, so f of x plus 1 equals 3x. There's no other x terms, just adding like terms, and 3 minus 2 is plus 1. Say we had something a little bit harder. Number 2, h of x equals 2x minus 1 over x squared plus 2. Only doing 2 because it's not too hard. First one, say it's at h of 0. So we just plug in x equals 0 into all our x's in here. That's all it wants us to do. 2 times 0 minus 1 over 0 squared minus 1. Well, 2 times 0 is 0, so that term goes away. We just have negative 1 divided by 0 squared. 0 minus 1 is negative 1, so we get 1. Of course, it does get harder. Say it said plug in 2x. Okay. Well, we have 2 times 2x minus 1 over 2x all squared minus 1. Well, 2 times 2x, just multiply the numbers, is 4x minus 1 over 2x squared. We're actually squaring both of these. 2 squared is 4, and x squared is, well, x squared. And the 1 doesn't change. So that would be it for that one. Hope you enjoyed today's lesson on functions.